Today our topic is infinite geometric progression. Yesterday we discussed that what is geometric progression. Then there are two types of geometric progression. Geometric progression, I said, the progression in which the common ratio between two terms is same. Similarly, then we can talk about there are two types of geometric progression. For example, 1, 2, 4, 8, 16, and up to so on. And the other one, if I said that 1 by 2, 1 by 4, 1 by 8, and 1 by 16, up to so on.
Okay.
Actually, both sequences are geometric. There is just only one difference. One sequence, if you consider this sequence, this purple color, so this sequence is actually by increasing label, the term is also increasing. 8, 16, 32, and up to so on 64, and after some time this would become a huge, a very large term. While in
Okay.
this term, if you look at this by increasing label, label mean first, second, third, fourth, and fifth term, while you increase label, the term actually becomes smaller, because if you look at this, this is 1, so this is 0.5, while this is
Yeah.
0.25, this would be
Yep.
0.125, and this is maybe 0.1 something else, so 0, it, etc. So now this sequence is called divergent sequence because it is divergent, by increasing term either in positive direction or in negative direction. It is called
Okay.
divergent sequence, while
Mm.
this one is called convergent sequence. It is converging, just let me write down convergent sequence. So this sequence is actually converging to the term when we increase this 1 by 16, then 1 by 32, 1 by
Mm.
64, 1 by 128, and then 1 by 256, and then 1 by 1 512, and then 1 by 1024, and up to so on.
So the bottom,
So,
so the bottom keeps doubling while
yes,
the top stays the same, and as such, the numbers keep going lower.
exactly. So this would become 1 by 1024 is equal to 1.00 something else. So this actually sequence is converging to the term 0. Okay, we can say that this
Okay.
term is converging to the 0. Okay, now just look at this. How can we calculate the sum of these sequence for divergent sequence and for convergent sequence? So for divergent sequence, like if I calculate the sum of 10 terms, so it would be the first term was A, while A into 1 minus R, then R is 2 and power 10 divided by 1 minus R, 1 minus 2. So it would be 1 into 1 minus 2 power 10. This is for divergent sequence. But
Okay.
then 2 power 10 would be 1024 divided by minus 1. So the final answer would be minus 1023 divided by plus 1023. So
Mm.
if we want to calculate S11, so it would be 1 into 1 minus 2 power 11 divided by 1 minus 2. So it would be 2 power 11 is 2048 minus 2047 divided by minus 1, minus and minus cancel, and 2047. Just adding only one term, there is a huge difference between sum S10 and S11. Okay, but for convergent sequence, now look this phenomena for convergent sequence. For convergent, where
Okay.
A was 1 while R was 1 by 2. So the sum of 10 terms, if you look at this, this would be 1 into 1 minus r power n, 1 by 2 power 10,
Okay.
divided by 1 minus 2. So 1 minus 1 by 2 would become 1 by 104, 1024.
Sir,
You,
this
just 1
formula
minute.
would only be used. No, sir. Just 1 second. This
Yes.
formula would only be used if r is less than 1. Yes.
Just listen, please. Don't
Okay.
confuse with those formula. There is just only one formula for geometric sum. Okay.
Okay.
No need to confuse with the other formula. I said you have to use just only one formula, that is 1 minus a rn, a into 1 minus rn divided by 1 minus r. Okay. So don't confuse
Uh,
with the book formula. So this would be the 1 0. Just let me this is 1 0 1 minus 1 r. So 1024 minus 1 divided by 1 minus 2. So when you take 2 power 10s, so 2 power 10 in 1024. Just 1 minute by use, I will calculate it by using calculator. So,
no problem.
or for 1 minute.
No problem.
So this would be 1 minus the above. This 1 by 2 is 1 by 1024
Mm.
divided by 1 minus 2 will become minus 1. No, this was also, sorry, I put here 1 by 2. So it would be also 1 by 2.
Uh,
1 by 2 mean it is 0.5. Here I put here I put 2. So we have to put a 0.5. So in denominator, this would become 0.5, or
okay.
1 minus half will remain half. 1 by 2,
Uh,
either you can put 1 by 2 or plus 1 by 2 or 0.5. So this 1024 minus 1, 1023
okay.
divided by 1024. While divided by 1 by 2, it means we can say that 2 by 1. So the final answer will be, by using calculator, let me calculate it. 1023 multiplied by 2 is equal to this, and divided by 1024 is equal to this. So it would be 1.998. 1.998. So this is the sum of 10 terms. Now we are going to calculate the sum of 11 term for this convergent sequence. So S11 would be just, I will write it directly, 1 minus 1 by 2 power 11. So divided by 1 minus 1 by 2. So for this would be 2048 minus 1 and 2047 divided by 2048 and multiply by 2 by 1. So let me calculate it. 2047 multiply by 2 divided by 2048. It would be 1.999. So the final answer will be 1.999 and 9. Now look, compare these two sequences. While we have, when we calculate the sum of 10 term in geometric sequence, that was 1023, and when we add just only one term, and that is would become 2047. While in convergent sequence, when we calculate the sum of 10 term, it is just only 1.998, and sum of
Mm.
11 term is just 1.99, just only a small change on a third decimal place. So we can say that when r is in fractional, or between, in between 1 and -1, so this whole digit will become so small. This,
Mm.
if you are
Okay.
looking at this 1 by 2. So
Yeah.
let me write down the formula of that sequence. The sum formula is Sn is equal to a 1 minus Rn divided by
Okay.
1 minus r. So actually this would become so small, like it approaches to 0 when n approaches to infinity. Like when n approaches to infinity, this will approaches to 0. So 1 minus 0 will remain 0. 1 minus 0 will become 1, while 1 minus r will as it is. So the formula for s in infinity will be simplified as, this is called S infinity, a over 1 minus r. This is the
Okay.
formula for S infinity
A. Okay.
over 1 minus. S infinity mean we can calculate the sum of infinite term in convergent sequence. I said when we increase the label, then the term coming at 11th or 12th number is actually do not affect the sum. So it's just a small change. There is no, there will be no change up to 3 decimal place. 1.999, it will remain same. While if we add some more term,
Okay.
maybe it affect just only a 10th decimal place or 11th decimal place. Though overall the figure or
Right.
overall the sum will remain same. So we can say that in convergent sequence we can calculate the sum of infinite terms, that is a over 1 minus r. And there is small restriction when we use this formula when r is in between 1 and -1. Okay.